Hello and welcome to the CompTIA Cybersecurity Analyst, CySA Plus Certification Study Guide. In this video, we will discuss Chapter 3.2 Access. Please like, subscribe, and hit the notification bell. Second, instead of generating a one-time password, an authentication code is sent in a text message to a smartphone. After entering a username and password, a text message with an authentication code is sent, and the user must enter that code on the website to complete the authentication process. This can result in a higher degree of security because it combines more than one type of authentication credential. It uses both what a user knows, the password, and what the user has, a smartphone. Using two or more forms of authentication credentials is called multi-factor authentication, or MFA. An even simpler approach is an app installed on a smartphone that requests the user's approval. This prevents a remote attacker from impersonating a user by entering their password, since it would require approval from the genuine user. A user who receives a request but was not attempting to log into an account with a password would simply deny the request. Using an authentication app is shown in Figure 3-2. Despite its convenience and ability to reach a wide range of users, using a text message sent to a smartphone for authentication is not considered a secure option. A text message can be phished. A user is tricked into providing the code to an attacker through a phishing attack. Text messages can be intercepted, and an attack known as MFA fatigue generates a seemingly endless stream of MFA push notifications sent to the user's smartphone, who simply accepts the MFA push notification in order to stop being bothered. A more secure option that is gaining acceptance is using a dedicated token key, known as a security key. As seen in Figure 3-3, a security key is a dongle that is inserted into the Universal Serial Bus (USB) port, or held near the device, such as a smartphone using near-field communication or NFC. The key contains all the necessary cryptographic information to authenticate the user. One feature of security keys is attestation. Attestation is a key pair that is burned into the security key during manufacturing time and is specific to a device model. It can be used to cryptographically prove that a user has a specific model of device when it is registered. When a user creates a new credential key pair that links to a specific service like Facebook or PayPal, the public key that is sent to the service is signed with the attestation private key. The service that is creating the new account for the user can verify that the attestation signature on the newly created public key came from the device. Because security keys do not transmit OTPs or authentication codes, many security professionals recommend that users choose security keys for authentication. One of the problems facing users today is the fact that they have multiple accounts across multiple platforms that all should use a unique username and password. The difficulty in managing all of these different authentication credentials frequently causes users to compromise and select the least burdensome password, and then use it for all accounts. A solution to this problem is to have one assigned username and password to gain access to all accounts so that the user has only one username and password to remember. Using a single authentication credential that is shared across multiple networks and has interoperability, the ability of systems to exchange information, holds great promise for the user. When those networks are owned by different organizations, it is called federation, sometimes called Federated Identity Management or FIM. One application of federation is single sign-on, SSO, or using one authentication credential to access multiple accounts or applications. SSO holds the promise of reducing the number of usernames and passwords that users must memorize, potentially to just one. There are several current technologies for SSO. One of the most common is Security Assertion Markup Language, SAML. This is an XML standard that allows secure web domains to exchange user authentication and authorization data. It allows a user's login credentials to be stored with a single identity provider instead of being stored on each web service provider's server. SAML is used extensively for online e-commerce business-to-business, B2B, and business-to-consumer, B2C transactions. The steps of a SAML transaction, which are illustrated in Figure 3-4, are: the user attempts to reach a website of a service provider that requires a username and password. The service provider generates a SAML authentication request that is then encoded and embedded into a URL. The service provider sends a redirect URL to the user's browser that includes the encoded SAML authentication request, which is then sent to the identity provider. The identity provider decodes the SAML request and extracts the embedded URL. The identity provider then attempts to authenticate the user either by asking for login credentials or by checking for valid session cookies. The identity provider generates a SAML response that contains the authenticated user's username, which is then digitally signed using asymmetric cryptography. The identity partner encodes the SAML response and returns that information to the user's browser. Within the SAML response, there is a mechanism so that the user's browser can forward that information back to the service provider, either by displaying a form that requires the user to click a submit button or by automatically sending it to the service provider. The service provider verifies the SAML response by using the identity provider's public key. If the response is successfully verified, the user is logged in. OAuth relies on token credentials. A user sends their authentication credentials to a server, such as a web application server, and also authorizes the server to issue token credentials to a third-party server. These token credentials are used in place of transferring the user's username and password. The tokens are not generic but are for specific resources on a site for a limited period of time. For many years, technology pundits have said the death of the password is right around the next corner. However, these statements have turned out to be false. The promoted password alternatives, such as SSO, were sometimes found to introduce as many usability and security problems as they solved. Now, however, cybersecurity may truly be on the verge of having strong and user-friendly authentication systems that do not use passwords, called passwordless systems. One passwordless system that is rapidly gaining popularity is called Passkey. Passkey is supported by Fast Identity Online, FIDO, an open-source organization whose aim is to reduce reliance on passwords. It is backed by some of the world's biggest tech companies, such as Google, Apple, and Microsoft among its 250 members. FIDO standards are built in almost all web browsers, operating systems, OSS, and consumer devices used in online transactions. Instead of relying on passwords, Passkey utilizes a hardware device to verify a user's identity, such as a mobile device, smartphone or tablet, USB key, or an NFC-enabled device. Passkeys are based on WebAuthn or web authentication, which uses public and private keys to verify a user's identity. The public key is shared with the website to which the user wishes to be authenticated, while the private key is kept secret. When a user signs up for a new account that utilizes Passkey, the website's server shares information and asks the user to confirm their authenticator. A passkey, including the public and private key pair, is then generated for that specific website. The public key is sent to the website server for storage, while the private key remains securely stored in the user's authenticator. When the user attempts to sign in using passkey, the website will create a challenge that is sent to the user. The user's authenticator will first verify the user's identity through biometrics like a face or fingerprint. A master password can be used as an option, before signing the challenge using the private key and then sending the completed signature to the website. Finally, the website uses their copy of the user's public key to verify the signature's authenticity. Passkey is illustrated in Figure 3.6. Passwordless systems like Passkey have several advantages. Strong by default. Because users no longer create passwords, there is no concern whether a password is strong. Instead, the authenticator device generates a strong and secure public and private key pair on the user's behalf, no external exposure. Since users no longer enter a password, it cannot be exposed to threat actors. The private key is stored on the device and retrieved automatically, and the public key is stored with the account provider. Cannot be stolen. Because the password is not stored on the remote website, there is nothing for threat actors to steal. And if the user's public key were to be stolen, it would be useless since by itself it cannot be used to gain access to the account. Immune to social engineering attacks. Threat actors who create impersonated fake websites and then use social engineering and phishing attacks to trick users into entering a password will find that these attacks are no longer effective. WebAuthn ensures that users cannot share their credentials with untrusted websites. In late 2023, Google announced that passkeys are now the default sign-in option across Google accounts for all its services and platforms. A second category of IAM topics focuses on access. Two access technologies are privileged access management and a cloud access security broker. Privileged access management, PAM. Privileged access management includes knowing the definition of privilege, types of accounts, and why PAM is needed. What is privilege? In cybersecurity, privilege is more than the authority a given account or process has within a system or network. Instead, privilege is a special right. That is, it is an advantage or elevation above what is normal and is not ordinarily given to a wide range of users. Privilege provides the authorization to override or bypass important established security controls and may include permissions to perform actions such as shutting down systems, loading device drivers, configuring networks or systems, and provisioning and configuring accounts and cloud instances. Privileges serve an important operational purpose by enabling users, applications, and other system processes the elevated rights needed to access certain resources to complete necessary tasks. Types of accounts. In virtually all organizations today, there are two types of accounts: non-privileged accounts and privileged accounts. Most users are assigned non-privileged accounts, also called least privileged user accounts, LUAs. There are two types of non-privileged accounts. Standard user accounts. Standard user accounts have a limited set of privileges, such as for internet browsing, using certain types of applications like Microsoft Office, and for accessing a limited array of resources. These are defined by role-based access policies. Guest user accounts. Guest user accounts possess fewer privileges than standard user accounts. These accounts are usually restricted to basic application access and internet browsing. At the other extreme are privileged accounts. A privileged account provides access and privileges beyond those of regular, non-privileged accounts. Special types of privileged accounts, sometimes called super-user accounts, are primarily used for administration by qualified and pre-approved information technology, IIT employees. These employees must be approved because privileged accounts provide virtually unrestrained power to execute commands and make system changes. Super-user accounts are typically known as root in Unix and Linux. In Windows systems, they are simply called administrator. Super-user account privileges can provide unrestricted access to files, directories, and resources with full read, write, and execute privileges. The power to render system-wide changes across a network, creating or installing files or software, modifying files and their settings, and deleting users and data. Super users can even grant and revoke privileges permissions for other users. A Windows computer has at least one administrator account that allows the user to perform activities such as installing software and changing local configurations and settings. While Apple users may operate with root access as a default, a non-privileged account should be created and used for routine computing. However, there is also a middle ground between these two types of accounts. As a best practice, most users only have a standard user account, but some users may need to occasionally perform higher-level activities. To facilitate this, these users are given both types of accounts. They log in as a standard user to perform routine tasks, but then log in using a super user account to perform administrative activities. Because of their elevated capabilities and access, privileged accounts pose considerably higher risks than non-privileged accounts. It is important for these privileged accounts to be strictly managed and controlled. However, often these privileged accounts are not properly managed due to a variety of reasons. Over-provisioning privileges. Because user accounts are not always matched with job responsibilities, users may complain that they cannot do their job. IT administrators then provide users with broad sets of privileges that go beyond what they need. Also, an employee's role can change and no longer require elevated privileges, or they have new responsibilities that allow them to access critical corporate data, but still have dangerous privileged accounts. Lack of visibility and awareness. Long-forgotten privileged accounts are commonly sprawled across organizations. These orphaned accounts may number in the hundreds or even thousands. Manual and decentralized management. Managing hundreds or thousands of privileged accounts manually is virtually impossible. Also, privileged accounts may be managed differently across different parts of the organization that leads to inconsistent enforcement of established best practices. Lack of visibility into privileges. Applications and service accounts often automatically execute privileged processes to perform actions, as well as to communicate with other applications, services, resources, and so on. Applications and service accounts frequently possess excessive privileged access rights by default. Shared accounts. IT teams commonly share root, Windows Administrator, and many other privileged credentials for convenience, so workloads and duties can be seamlessly shared as needed. However, with multiple users sharing an account, it is impossible to tie actions performed with an account to a single individual. This creates security, auditability, and compliance issues. Siloed processes. Modern IT environments typically run across multiple platforms: Windows, Apple, Unix, and Linux, and environments, on-premises, Azure, Amazon Web Services, and Google Cloud. Each of these is often separately maintained and managed. This results in inconsistent administration, added complexity for users, and increased risks. The solution is Privileged Access Management, PAM. PAM is the strategies and technologies for exerting control over privileged accounts and the access and permissions for users, accounts, processes, and systems. It provides visibility, control, and auditing capabilities. PAM is considered a subset of IAM. While IAM controls provide authentication of identities to ensure that the right user has the right access at the right time, PAM layers on more granular control over privileged accounts and session activities. Taken together, IAM and PAM can provide fine-tuned control, visibility, and the ability to audit across all credentials and privileges. As with applications running in an on-prem environment, cloud-based applications must also be protected. However, there are several common misperceptions about applications running in the cloud. One misperception is that application security is entirely the cloud provider's responsibility. Another misconception is that the native, out-of-the-box security of the applications being licensed will provide adequate security. In addition, misconfigurations of the application setup and insecure APIs or interfaces can provide vulnerabilities for threat actors to exploit. One security protection for cloud computing application security is to use a Cloud Access Security Broker, CASB. A CASB is a set of software tools or services that resides between an enterprise's on-prem infrastructure and the cloud provider's infrastructure. Acting as the gatekeeper, a CASB ensures that the security policies of the enterprise extend to its data in the cloud. For example, if the enterprise has a policy for encrypting data, a CASB can enforce that control and ensure that data is encrypted when it is copied from the cloud to a local device. Another security protection is to use cloud-based data loss prevention, DLP, to extend the enterprise's policies to data stored in the cloud. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.